In this video, we are going to talk about static SLA policies that are part of Juniper CSO SDWAN solution. So we will see how by manipulating a static SLA policy, we can achieve that traffic takes a certain path. So let's set up the stage for this test. So we have a spoke device, which is NFX250, a hub device, which is SRX4200. CSO has already provisioned or spawned a VM, which is VSRX, and established tunnels between the spoke and the hub device. The spoke device currently have two WAN links that we are going to call 002 and 003. One of those links will be MPLS, the other will be called Internet. There are also two tunnels going over these two links. One is green and the other is red. So these two numbers are important just for the screens where we see outputs from the device terminal. So what's the idea here? Let's imagine that there is a lot of Twitter traffic between Spoke and the internet. So if there is no policy, any kind of policy, this Twitter traffic, assuming that both of these tunnels lead to the same destination, the Twitter traffic will be balanced by ECMP over both of the two interfaces. For some reason, the administrator of this system wants Twitter traffic to be nailed down to the internet link. So it wants to relieve the MPLS interface from carrying the Twitter traffic. Why? Because let's think they they know that the MPLS link is a business critical link, and social networking should be done, or that traffic should be diverted on the less important link, which is in this case called internet or red tunnel. So the administrator wants to achieve to move the traffic completely from MPLS to the internet, and in end state, the Twitter traffic should be using only the red tunnel. So let's see what our system looks like from the CSO perspective. The device that we are going to observe this is NFX17. We see number of tunnels that are going from that device to the hubs. We are interested only in those two tunnels, the red and the green one. We also see that a lot of Twitter traffic actually is currently flowing over this system. And also we notice that there are no SLA profiles currently defined, nor SDWAN policy. So the current state and the output from the VSRX device are showing that this particular Twitter traffic is spread almost evenly between the two WAN links, number 2 and number 3. The 4 is our LAN interface. So we are just looking for the WAN links, which are 2 and 3, and we see that sessions are almost equally distributed between those two links. So currently, let's see that one of those sessions. So we see that the system has recognized this as a Twitter application. We also see that traffic is currently, this particular session is using the internet link. Let's find some other session. The next one below, we see that it's using the MPLS tunnel. So let's see how many of these sessions there are. So this is not like one session, it's like more than one. So let's count them. And let's do the same thing for another tunnel. So we are matching here on the MPLS tunnel, and here we are matching on the internet tunnel. The tunnels that are going via two links that we call MPLS and the internet. So we see that number of sessions pretty much are distributed equally among both links. So let's see what kind of traffic is this. So this is not like one session. We see that a number of TCP sessions, this is a rate of TCP establishment. So it's a little bit random. That's why these numbers actually oscillate. So in summary, we see that how many sessions are being established and closed per second. And here we see some kind of total number since the beginning of the test so far. The system is counting. So let's now go and define our SLA policy to achieve the goal of moving traffic completely from here to there. So from MPLS side to the internet side. Or in other words, let's empty completely Gigabit Ethernet 002 link from the Twitter traffic. First, we are going to define an SLA profile. We can call it Twitter static. We can also define a forwarding class for this traffic. But the important part is the path preference. For SLA, static SLA profiles, we need to choose between those two links. So for Twitter, we said we are going to move that traffic onto the red path, onto the internet path. And here we are done. We don't go and change anything below this line. Anything below SLA parameters, we don't touch. If we touch anything there, then this is not anymore a static SLA policy, but becomes dynamic SLA policy. So we just skip completely everything that is below SLA parameters. When we are happy with what we have here, we are going to save the SLA profile and attach it to a particular policy. So let's create a policy. We are going to apply this to our spoke site number 17. Application is going to be Twitter. We have two applications that has Twitter in their name. So let's choose both. Let's apply a particular profile that we defined and give the name for this intent. So intent, again, in this particular case is to move particular application, in this case Twitter, to use only the internet link. And save. So let's now deploy this policy. Currently, the deployment is in progress, and we are now going to move and observe what's happening with the new sessions. As new sessions get established, the policy, once committed on the device, will immediately start moving or putting those sessions onto the internet link. So we expect this number to go down and this number here to go up. Also, we should see that one interface 002 should start the amount of traffic on that link should start going down. That is already happening. And finally, we see that slowly number of sessions of Twitter session. We were matching on the Twitter sessions. The number of Twitter sessions is now 0. And number of new sessions here is doubled what was previously distributed between both lengths. This concludes our demo on static SLA policy.